The chemical industry does use a wide range of hazardous materials. For example, we might use sulfuric acid in the manufacture of detergents. The detergents themselves are not harmful, but the sulfuric acid is potentially dangerous. Likewise, there are intermediates that go into the manufacture of shampoo, which are made using cyanide. If you're going to carry out a process of that type, you need to be careful. And clearly at Bhopal, they weren't.
The disaster's origins lay in the particular way in which Union Carbide chose to make Sevin.
Chemistry is a little bit like cooking. If we're trying to make a molecule like Sevin here, what we'd like to do is to buy the ingredients off the shelf. We don't want to have to make any complicated intermediates if we can possibly avoid it. The molecule here, Sevin, is made up of this part, which we can buy essentially off the shelf. More problematic is putting this part on here. The process that Union Carbide used at Bhopal started with the reaction of carbon monoxide and chlorine to make phosgene.
Phosgene provided one of the crucial building blocks for methyl isocyanate, or MIC, which in turn became a component of the Sevin molecule. Phosgene had killed a worker 3 years earlier, in a foretaste of the agony still to come.
Ashraf Khan, a maintenance worker, was working in this area. He was wearing a breathing air hood and only dungarees below that. Phosgene splashed onto him and soaked his dungarees. He panicked and he ran for a shower this way. He came here, he removed his hood. The phosgene which had penetrated his clothes evaporated. He inhaled that and he died in hospital a few days later.
Phosgene became infamous when it was used in warfare, and most infamously during the First World War. It's relatively insoluble in water, and when released it creates a white cloud quite close to the ground, and I understand smells of new mown hay. Because it's insoluble, if you breathe it in, it won't get absorbed at the upper end of your respiratory tract, but will reach the furthest, deepest parts of your lungs. This is a picture of those deep parts of your lungs. It's these membranes that phosgene damages. If you breathe in phosgene, these membranes will be destroyed and blood will flood into your lungs. In effect, you will drown in your own blood.
As phosgene was so lethal, the plant only ever stored enough of it to satisfy one day's production. That way, even if there was a release, the scale of the problem would be minimal. But phosgene is merely one ingredient for the chemical that was to kill thousands.
The next step in the process is to put this group on. You can do that in a number of ways. You could add on this bit and then that bit, but Union Carbide chose to do it in one go, a single reaction. Now that's cheaper and potentially a lot cleaner, so it has some advantages. The downside is that the chemical we need to do that is methyl isocyanate, which is extremely dangerous.
In contrast with phosgene, MIC was stored in 3 vast tanks, originally buried in a concrete bunker near the edge of the plant. 40 feet long and 8 feet in diameter, each was capable of holding 42 tons of the potentially lethal chemical. Where phosgene was a famous killer kept in small quantities, MIC was stored on a scale that would kill thousands. "8:45. The pipes that were being washed started to become choked with the dirt being carried by the water. The nozzles became blocked and water began to back up, flowing into one of the main pipe systems that ran throughout the plant.
MIC is very handy stuff. It reacts to produce particular molecules that we probably couldn't reach easily by other chemistry. So it's very useful to the chemist. He can build things in a way that he wouldn't otherwise be able to do. It's also reactive, which means that things that happen fast. We don't need very long reaction times, and we tend to get perhaps cleaner chemistry, fewer waste products. However, the reactivity is a problem. It means that it's going to react with a whole range of things it might come into contact with. Water, for example, or worse still, people.
Keeping MIC apart from water is vital, because if the two liquids mix, anybody nearby would be in serious danger.
MIC is a highly irritant gas. It has two important physical properties that make it particularly unpleasant. The first is that it's very soluble in water. And the second is that it vaporizes or boils at a temperature almost exactly the same as the body. This means that if you inhale MIC at low concentrations, it's going to affect in the first place those parts of your body that are wet, which will absorb the MIC. That's your eyes, your mouth, your throat, and your upper airways. At high enough concentrations, it'll get the whole way down to that part of your lung where oxygen is transferred into your bloodstream. And very similar to the effects of phosgene, if that part of your lung is damaged, then serum will flood from your bloodstream into your lungs, and you'll